Good morning, good afternoon, and good evening, ladies and gentlemen. Welcome to our highly anticipated webinar titled as Need of the Hour, Evolving from Monitoring to Observability. I am Vikas, your technical assistant for today's session. Before we dive deep into our engaging discussion, let's quickly go over some housekeeping items to ensure a smooth webinar experience. First, please ensure your microphones are muted throughout the session to minimize background noise and any interruptions. Number second, utilize the chat box on your screen, on your Zoom screen, to ask questions, share your thoughts, and engage in the discussion with the fellow participants. Number third, our speaker will address your question during the dedicated question and answer session, which is available at the end of the presentation. Please feel free to submit your queries throughout the chat box during the presentation. Number four, if you encounter any technical difficulty, please reach out to a technical assistant, that is me, Vikas. And the last is, please note that this webinar is being recorded and the recording will be available to all registered participants for future reference. I'm thrilled to introduce our first speaker, Mr. Samson Samuel, a renowned expert in security and analytics domain, and also the Director of Data Analytics and Security at Positka. Mr. Samuel brings a wealth of experience and expertise in data security and analytics. Without any further ado, I'll hand it over to Mr. Samuel to introduce himself and the other speaker. Over to you, Sam.
Uh, Thank you everyone for joining today's session. I know it's early for some of you, late in the evening for others. Appreciate the time. Uh, so I will be, I guess, taking the first part of the seminar today. I also have a colleague with me, Vikesh. He's one of our architects and consultants. He will be doing a more detailed dive on whatever I talk about in the first half, in the second half. Let me just quickly go through the agenda. My screen is visible, I'm assuming. Yes? Great. So in terms of today's agenda, so I think there's a small bit that I wanted to address first about monitoring versus observability. We keep hearing about this. So I just want to touch a little bit upon that. What do you mean by observability? What are the key components? Uh, uh, I think there are many observability tools out there. I think one of the things we wanted to touch upon today was Splunk in particular, what it brings to the table. There'll be a detailed demo session of a lot of the key elements we will see early on. And of course, my colleague Vikesh will be taking that demo later on. And then, as Vikas mentioned, we'll have some Q&A and we can close out. During the session, of course, if you have questions, please do feel free to type that out in the chat box. I think Vikas and Vikesh, they'll be looking at it and we will try to keep answering questions as we go along as well. The first section that we wanted to, I guess, cover was monitoring versus observability. And before I get into the nuts and bolts, I think there are some interesting images I came across, which I just wanted to share here, right? So, for example, this tweet talks about how a monolithic application was replaced with microservices, so that the team spends more time becoming detectives and they try to figure out where outages are. So it's like a murder mystery every time there's an outage. So I think that to some extent is a reflection of the fact that now that we are going into more complex environments, we are going into high velocity releases, it's bringing with it its own set of challenges. And I think teams everywhere, they're struggling with it. So that's something that is the new reality now. I think another thing that comes up very frequently is again people call observability new wine. I'm sorry, old wine in a new bottle, right? So here you've got this comment that because DevOps or dev teams don't like to do monitoring, they want to make it sound more, I guess, jazzy by calling monitoring as observability. So is that really the case? And are APM and observability the same, or are they different? So I think there's a lot of discussion, there's a lot of debate around it going on. So by the time we get to the end of the first half, I'll try to make sure that I present my perspective. Of course, everyone will have their own perspective. So we'll talk a little bit more through all of this. Uh, Now, of course, everyone's moving towards microservices. So 15, 20 years ago, even more recently, monolithic applications were the norm in the industry. So whenever you develop an app, you sort of package it into a single massive application, and you have a lot of interfaces that you open out to it. But now you have moved to a world where you have a lot of microservices within your environment that are running, and each service, of course, brings with it its own complexities. So the front end, the back end, the kind of technology, the technology that you use, the underpinning infrastructure. Are you running it on containers? Are you running it on a cloud platform? Are you running it on virtual machines? It's a very complex environment now. So the by virtue of the fact that you use microservices, you are increasing your agility, of course, but along with it, you are bringing in quite a bit of complexity in terms of finding out what's happening in your environment. In addition to just microservices themselves, I think the environment that these microservices operate in, or these traditional applications operate in, that also adds to the mix. So you will have your traditional data centers, for example, where you'll be running virtual machines on hypervisors. That's the traditional model. That's the traditional model. Now you're sort of moving to a more hybrid environment where you'll have virtual machines, you'll have Dockers, containerized environments, you're running microservices quite a bit. And now, of course, as you evolve more, you're starting to go more into serverless environments. Now, if you are an organization, and then, for example, if you're a bank, you are going to have different applications, different consumers of the applications. It could be your bank branches. It could be your customers who are consuming your services through online banking. They could be using mobile banking, more and more prevalent. And then you're going to have a lot of business applications or business services which are servicing all these different channels. Each of these services in turn is underpinned behind the scenes, of course, by infrastructure, by applications, by microservices, monolithic applications that are again split across this hybrid environment. So depending on the size of your organization, be it a large conglomerate that's multi-country versus maybe a smaller startup, there is bound to be varying levels of complexity. You either have a single environment, you still have complexity. You have multi-geography, multi-data center, hybrid environments, a lot more complexity. But regardless, there is going to be a level of difficulty to manage these kinds of environments. As you deploy code, as you develop and push things faster, new features, new functionality, things are bound to break. So it's not a question of will it break or not. The question is, are you able to catch it ahead of time? Are you able to resolve it quickly so that customer experience does not suffer, right? That's where we are getting to. So if you look at for in a nutshell, if you look at what is the typical approach to modern application development now, there are a couple of goals that I think most IT teams are trying to achieve, most application teams are trying to achieve. So one is they want to simplify the management of their environment. They want to reduce the impact of pushing in code so that their code base is not brittle. It's able to withstand high velocity of changes. They want to get to a stage where they are able to get improved efficiency because they are able to automate as much as they can of their day to day. They want to accelerate the delivery of high quality services which the business is looking for. So that is the driver of growth. That is the driver of revenue from a business perspective. They want to get insight across resources and applications. And of course, they also want to protect customers and the business. Now, how are they doing that? When they talk about environment management, you talk about serverless technologies coming in now. So the more you're on serverless, the less infrastructure headaches you have to worry about. How do you reduce the impact of code changes? You bring in microservice architecture so that whatever change you make is restricted to that service alone. It doesn't impact the rest of it in an ideal world. You are bringing in infra as code, you're bringing in app modeling, you are using continuous integration, continuous development pipelines to accelerate the delivery. You're bringing in observability to get insight. And of course, you're also looking at end-to-end security and compliance. So for today's discussion, even though there are, I guess, all these different ethos to deal with for the modern application developer, we'll focus more on observability. The rest of it, of course, is very important. Cannot downplay the downplay how important those tenets are. But for today's session, I think we will stick primarily to observability and how it factors into that larger landscape we are talking about of the modern application developer ethos. Uh, Moving on to, I guess, why observability matters. I guess if you look at this chart, for example, where we are talking about latency. So latency is, for example, a key metric that's going to talk about how your application is performing. So if you have a certain normal way of operating, typically what happens is that you have some kind of a degraded state of operations that occurs where your key metrics, your indicators start going haywire, but they are not, your system is not down yet, you don't have an outage yet. But ultimately, your degraded state is going to lead to an outage. So to a large extent, when we talk about monitoring versus observability, I think the bottom half that we're talking about, what you want essentially is a system that allows you to keep an eye on what's going on. So there's no real problem in the bottom half, as you see now, but you are seeing that the performance is starting to deteriorate. So there's an indicator that things might go wrong. So ideally, this is the place where in today's day and age, we want to move to proactive operations. We want to move into observability. At the point where you have an outage, you're going to have customers call in, you're going to have error messages, you're going to have your thresholds being breached and all. So typically, or I would say more traditionally, this is where monitoring has operated in the past. If you talk about just APM tools and all, typically they are looking more at the point where something has already occurred, and then you try to trace back and find out what happened and you fix it. So you're not proactively looking to begin with about is there any deterioration in your performance. So in a nutshell, I think to some extent that captures the essence of what is the difference between observability and monitoring. Now, if I just drill down on that a little bit more. Now, what you see here, this is an example of course, a black box. So when you talk about a black box, this is something that is seen by the end user in the context of applications. It is something that you are seeing from outside, you are observing it externally, and there are certain things that you can get from that. You can, for example, do a API call to see if you're getting a response or not. You can do a ping test. You can look at the response time. You can do a load time. But ultimately, all of this just highlights that it gives you a symptom of what is going on. It tells you that hey, the ping is slow, the response time is slow, so there's something happening within that box because of which this slow response. So you're getting some server unresponsive messages, response is slow, users cannot log in, but you actually at this point do not know what is happening inside this box. You just know that something is happening. That is where I think monitoring gives you that view. When you talk about observability, though, you are starting to look at what's happening inside that box, what's happening inside that system. You're looking at metrics, you're looking at logs, and you're looking at traces. And by itself, even if you don't have a specific outage at that point, it allows you to measure: is there a degradation that's happening? Is there an indicator of something that might be going wrong? And again, when you go to the root cause, for example, you might be getting server issues here, but observability will tell you that, okay, the database is refusing connection. That's why you're getting HTTP 500s. The responses are slow. That is because on the web server, requests are being queued and you need to find out why. Users aren't able to log on. That's because there's an issue with the authentication client. So this is where ideally what would typically happen is that this state that you see on the right under white box, this is what starts happening first. Once this happens, ultimately the end customer is going to see what you see on the right side. But unless you are actually looking at the metrics, the logs, the traces, unless you're observing all of this behavior, it's difficult for you to be able for you to predict what's going to happen. So that's again, I think one perspective of what is the difference between monitoring and observability. So black box versus white box. Now, in terms of black box monitoring itself, what are some of the, I guess, key principles around black box monitoring or regular monitoring, right? So it's more from a user slash business point of view. So is the application up? Is it running? What is the response time? There are certain service level indicators or service level objectives that you're trying to meet. Application uptime, again, the response time, utilization rates. Typically a little easier to understand what you're going to monitor. It tells you there's a problem that's going on. as I mentioned earlier, it's more reactive. It doesn't tell you that something is going to happen. It tells you something has happened, and then it's more of a last line of defense where you sort of it tells you that something's gone wrong. White box monitoring is slightly different, or observability, the intent of observability is slightly different. It is telling you what is happening with the components. This does not necessarily go back to the user business. It's just visibility into what's happening within your components. You can set thresholds, of course, here. Typically more harder to understand what you're seeing in observability because you're not looking for any one thing. You're looking at a number of things which might result in a problem. It can help you to detect something that's going to happen as opposed to something that is happening or has happened, and which is why it's more proactive and it tends to be the early alarm. This is where you also sort of start going, because you're looking at the issues ahead of time. This can allow you to do more automated remediation also of issues before they arise. With that, I'll also sort of go to what do you mean by full stack observability. So I think we spoke about observability, we spoke about monitoring. Now, what do you mean by full stack observability? So the key parts of any IT estate now that supports a business application or that supports business services are going to be, you're going to have an application layer, you're going to have a platform, and you're going to have infrastructure that's supporting your application and platform. And typically each of them has its own component. So you'll have some business metrics, for example, your revenue, the number of clicks, your churn. You'll have user metrics, how many users are logging in, then what is the response time for your website. You'll have transaction metrics, you'll have the software that's powering your applications. And then similarly for the platform, depending on whether you're containerized or not, you might have Kubernetes to monitor there, the pods and containers. And of course, finally, the last layer is where you get into the network, the storage, the compute, the operating system, all of that. So for observability, you need to be able to get a sense, get a view of what's happening across all of these different layers. And that's actually true observability. So what we are saying is that for all three layers and sub layers of what is given on the left-hand side, you need to be able to figure out what are the logs that are being generated, because that is going to give you the event level information for everything that's going on. You want to pick out the aggregate metrics, the CPU utilization, the memory utilization, the disk space, and of course, you also want to be able to look at customer requests. So if a request is coming in through your front end, going all the way through your microservices to a certain end state in the database, going back, you need to be able to trace that whole journey. And if you do all of it together, then that is going to give you observability across the application, the platform, and the infra stack. So I guess to end this section, I guess again a bit of light humor here. So you might call monitoring as a bit of a dinosaur, more in the past. Observability, I guess, the unicorn you want to get to. So are observability and monitorability the same? Are they equal? Well, I don't think there's a real answer. I think monitoring is evolving to observability, as you can see here. So I don't think anyone is saying that monitoring is going to go away or observability is the be all. I think the reality lies somewhere in between, where essentially monitoring is evolving now to become observability in the new paradigm. So I guess that is one part of the equation that I wanted to address in today's discussion. As I said, when we started out, I wanted to sort of share some perspectives about observability versus monitorability, because I think to a large extent that itself, that by itself is a point of debate at the moment. So I will pause here for a moment uh, if there's any questions there.
Hi, this is Dwarka. So I have one question. So, uh, do I like as you said that observability and equal to monitoring. So, let's say if anything happened in the real scenario, so what exactly we need to worry about? Like, do we need to focus on more into the observability or what?
So Dwarka, that's a good question, I think. So in terms of, I guess, the net impact or the end impact, what I think it primarily means is that you will have the tool sets to allow you to do your. So first is, before an issue happens, you should have an indicator that an issue is going to happen. If an issue has happened, then you should be able to see, okay, how do I trace it back down very quickly to where the issue happened, which is the monitoring part of it that comes in also. So in the second half, I think in another 5-10 minutes, Vikesh is going to start doing a demo, I think a bit of a case study about how that plays out. So if an incident occurs or is going to occur, how do you see that, and then how do you trace it back? So these are more of two. You can't do monitoring unless you have observability in place. So that's one more way of looking about it, if that makes sense. So it's just a tool set. It's extending your tool set so that you can detect things better and then take action or take decisions better, if that makes sense.
Okay. Yep. Thank you.
Thanks. Thanks, Bhagavan. Good. So I'll move. I'm sorry. Did someone else have a question?
We have a question from Utkarsh.
Okay.
It's like, yeah.
Okay. So I think Utkarsh is asking, does Splunk capture sample data or all data? So I think that will actually get covered in the next section also, Utkarsh, but just to jump the gun there. So Splunk, so again, I think there are different products out there. Splunk is one of them. Some of them do sampling of data. In the case of Splunk, it captures full fidelity, full tracing. So there's no loss of data there. Good. I will, in that case, move on to the next section. And I think there's a second poll also, if you can release that, Vikas. So if you can take 10-15 seconds just to sort of look at that, that'll be interesting to see. So does your team right now, wherever you might be, already look at observability data? I'm assuming there'll be some kind of monitoring in place, more likely than not. So you might have some EPM tools and all. So do you sort of do real-time monitoring, daily monitoring, weekly monitoring? Not much. Interesting to see that. Okay, I think we are close to 40% of the way through in terms of folks responding. Almost 3/4 of the way. We'll give it 5 seconds and wind up. Okay, looks like it's at the moment sort of run between real time and, or rather, continuous monitoring and daily monitoring, which is interesting to see. I think where we want to get to is continuous monitoring, okay, I'll end the poll also. Okay, great. Share results. Okay, so this is actually interesting. So I think it's a phase split between continuous and daily monitoring. So of course, where we want to get to is continuous monitoring, where the meaning of continuous not being that someone's sitting in front of a monitor glued to the screen the whole day, but your system should be working on behalf of you, and it should be raising up anomalies that need to be investigated. So that's a good mix. Interesting to see. And I will spend another couple of minutes very quickly because as we mentioned earlier, there are a lot of suites out there. There's Splunk, there's of course App Dynamics, Dynatrace. Everyone's coming up with their own observability suite. So today we are focusing more on the Splunk suite. I'll spend a couple of minutes sort of touching upon what Splunk has in its observability suite, and then in terms of the demo, Vikesh will take it forward in terms of making it more real in terms of what you're seeing. So on the observability suite, there's a very interesting module or feature set that Splunk has, which correlates more to AI ops, which is able to do more of the predictive detection, predictive analytics around what's going to happen as opposed to what is happening. So there's an AI ops platform. There's of course an APM module. There's something that does infrastructure monitoring. There's digital experience monitoring, which is more about what is the user doing. So or what is the user doing, or what is the user experiencing or seeing. So that is essentially what you would call real user monitoring or synthetic monitoring. So those components are there. There's something around how do you respond to incidents, how do you triage the calls that you're getting or the alerts you're getting, and there's a part around, of course, the log management or the log analysis part of it. So there are a number of modules. I think some of these Vikesh will touch upon. So there's something called Splunk IT Service Intelligence. This is more on the business and service reporting. So this is going to take data in from your different tools, could be from your APM, from your servers, from your Nagios, from all the different systems you have up and running, and then give you a consolidated view of what's happening across your business landscape. This is more on the AI ops side of it. Then you've got infrastructure monitoring, which is going to look at your underlying servers, your container, the health of your multi-cloud environment in case there's anything that isn't functioning as it should. There's a part around the traditional APM part of it. So this is more built around tracing and finding out how your requests are getting traced through the system. Correlates back again to, of course, your underlying infra and your business services. There's an element of real user monitoring, which is more of what the customer sees, and also synthetic monitoring, which is the part where you can simulate some tests to see what the end customers are experiencing. So I'll pause here. I think we're at the halfway mark almost. So I'll hand it over to Vikas now, or to Vikesh now, to carry on the demo. And of course, if you have any questions, please do feel free to type it in the chat box, or feel free to ask. Thank you, and over to you, Vikesh.
Thank you, Sam. Good. So, yeah. So I'll be running this demo a little quick. Like, I want to cover a lot of elements here. So in this demo, I will move quickly, across one of the real world incident. It's close to real world incident. So during this incident investigation, I will introduce the Splunk observability for IT and DevOps portfolio, like products like APM, RUM, and ITSI. And I will also show you how a comprehensive workflow, of a common incident that the SREs or the DevOps team typically will be collaborating day-to-day basis, and how the workflow, including alerting, will take place. Okay, so let me move on. So, okay, so I got an incident. Okay, so basically the incident came from one of the applications. Basically, the end customer is kind of selling t-shirts online. Okay, so I've got an incident which I need to take care of now. So this is, so for people who don't know about there's something called Splunk on call, formerly known as Victor Ops. So this is basically used for incident management. It's automated incident management where you can able to collaborate across different teams for a collaboration. So Splunk on call as a kind of automatic escalation, which is built right in. You can integrate with various tools. For example, it is integrated with the Splunk Observability platform. So whenever there's an alert triggered, it will automatically show up here. So there is an incident that I could see here. So this is from the Splunk observability, and I can see the host from where the incident is triggered. And so the main purpose of having an incident management platform is which enables the team to know the measure of MTTA and MTTR, whether the incident has been acknowledged, it's been worked by any of the analysts, or what is the status of the incident right now. I think this is very critical in terms of business perspective. So whenever there's an incident created, it needs to be addressed as early as possible. So yeah, here we also have the incident created. So basically for ticket managing tool, you might have a Jira or ServiceNow. So here we have a ServiceNow. So I can directly step into the ServiceNow. Before doing that, I can just acknowledge this ticket because I'm going to work on this ticket. So when I did acknowledge, I see the status change. I'm going to, investigate this, and then I will go to the ServiceNow now. And the status can be changed to progress. So this is just for tracking, tracking the incident that's been created. So once I have acknowledged and I have made status change, then I need to step into the investigation. So let's look a bit deeper into the incident details, right? So we know that this is the host from where the alert is triggered. So now let's go to annotation. Annotation section contains some other information. As I told you before, we have integrated the on-call with the ITSI and other observability suite products, so that it will provide us a kind of hyperlinks to run the playbooks or runbooks, kind of operating procedure, kind of sort of set of procedures guiding the analyst through next steps. So this is especially important, if they haven't encountered this type of incident before or are unfamiliar with this type of applications. So the event management will typically help in such scenarios. Here, as I already mentioned, there is an alert triggered for online t-shirt selling company. So let me actually go through the incident by itself. Okay, so the page, the dashboard, what we are seeing here is from the ITSI. This is for overall operation stands, such as we can able to see the severity distribution of the alerts that are generated. We have something called total noise reduction. You see, so this ITSA is running on the machine learning and AI ops, so that it filters out the noise. So out of 100%, you are just going to address 4%. That's very low when compared to the remaining 96%. So it's a huge win, for the analyst in terms of looking into the alerts. So let me go through one of the alerts that has triggered this particular episode. We can see the associated, on calls or victim incidents as well as the services which might be impacted. So we see these are all the 3 services that are impacted, and on the bottom you can able to see the number of key performance indicators that are associated with these services, which provides more clues as to what is causing the underlying problem. So we can see the transaction duration from the application performance monitoring, and we can also see the rate and errors coming from the real user monitoring. So these are some of the contribution KPIs which are tied back to the services, and it is directly affecting the health score of the entire application by itself. So let's take a look at the topology of these services. So Splunk ITSA provides beautiful insights on the topology view from top to bottom of the respective service. It helps us to understand better, for a business process, on a context of business. So here we see the Splunk T-shirt company is an online T-shirt company, and there are several dependent services running. And we see right now that there is an issue with the consumer website, and the downstream we see the checkout service, and the checkout service is affecting because of the payment service. So I can hover my mouse over each service, which will take me through the respective KPIs and what's the current status. So right now I see there's a problem with the duration from the RUM. Similarly, I can navigate to the other services like checkout service. Similarly, I can see the KPIs. There's a network delay on the checkout service, and finally there's a payment service, which seems to be the root cause. So in the payment service, we see there's a delay with the issues with the error rates, interaction count, and the duration. So typically, right, for example, I mean, we'll be using different applications for ordering food, right? Zomato, Swiggy, Uber, Grab, so on so. So it's not, it's a highly rare chance that we just open a single application and book the order or do the food order. It's not that case. We might parallelly open multiple apps, and if it gets delayed in one app, simply we will switch out to the other app and do the booking, do the food ordering. So what I'm trying to say here is that this is all business impact. If there is a delay in terms of user experience, then definitely as an end user we might need to skip to some other applications and do the bookings. That's how it happens. So now we know that there is an issue with the payment service, and we want to do the root cause analysis. We want to hunt for the root cause, a deep dive, to understand what the cause is actually because from the payment service. I will go to the deep dive. So this deep dive will help us to hunt for the root cause. It's a handy tool for correlating. So basically, there are multiple KPIs which are contributing to a service. So we can correlate across all the service over the same period of time to understand where the issue is lying around. Okay. So here we see the service health score, the payment service. It's not consistent. There's a, it's up and down trend. And there are certain factors which are impacting this? It looks like, we have a recurring problem which comes and goes at regular intervals, affecting both, APM and RUM, generating a lot of errors. So this is the first point that, we need to do the next level of troubleshooting. So what I do now, I will go back to my service analyzer. Okay. So for those who doesn't know what episode is in Splunk ITSI, episodes are nothing but logical grouping of alerts. So it will group all the similar alerts together and it will form a logical grouping. Now I'm going to investigate this further, so I'll just do an acknowledgement of this. Let it load. So here we can able to see in the event timeline, we can able to see the contributing alerts that are generated. So we can see 3 alerts generated and can have a small descriptions. It was triggered because of multiple critical notable events, because of the multiple KPI services that are over the threshold for last 15 minutes. So this is where you can able to see a overall information what is happening across your applications, and then from here, if I want to deep dive into the observability suite, I can go to the actions and I can explore. So on the first level, I will just investigate this in the RUM. So in real user monitoring, we can able to see the duration spike more clearly. We can able to see that there's a spike at this certain period of time. I can even filter it out to that particular period of time. So this REM suite, REM product provides much more detailed informations, which we can drill into more details for for these load times or by looking at the sample session. So we have some user sessions as well. So these user sessions will be helpful to understand what's happening when the user is experiencing some issues. If I drill down to one of the sessions, this will help me to trace to examine specific session in a great detail. So here I can able to see all the contributing factors, like there's a document load issue, JavaScript issue, there's some issues with the resource. If I scroll to the down, I will have a link to the respective application monitoring. I can see here the performance summary. So the performance summary, which says here, it's impacted by network, application, as well as the external components like other things. So I can quickly deep dive into one of the user sessions to understand more about the root cause. So from the RUM, I can directly jump to the APM module. In the API module, we see it's filtered to front end. So I will change this to all, so that you can able to see the complete topology. This is similar to the service analyzer view or what we saw in the ITSI. So this will really help you for tracing the context of where the issues. So now we are looking at the bigger picture containing the entire workflow. So as we see here, the red, there is a circle with red highlighted, kind of red ball. This help us to understand, okay, this is where the issue is lying currently. So now what I want to do is I need to deep dive into this specific module and I need to understand what the issue is. I can just hover my mouse here and I can have a overlook. There is a issue with the requests are not successful, there are some errors, there's a root cause. So we can able to see the latency as well as the duration, what is happening. From here, I know the issues with the payment service. So I need to know what are the contribution elements behind this payment service. So what I can do, I can go to breakdown. I can filter by, pod name. Now I'll have a better sense of what's happening inside the payment service. So there are 2 pods and one of the pod is facing the issue. This is what's happening right now. So one of the pod is facing the issue. Now I need to even more deep dive to understand what is the main reason behind the issue from this pod. Okay, so what I can do right now is that I can go to the log observer. In Splunk Observability Suite, so we saw the REM, which is real user monitoring. Now we are seeing at the APM, which is application performance monitoring. There is another component called log observer. So it will help us to provide a clear information or detail around what's happening in the environment. So I can simply click on the log observer, which will take me to the raw events. So I can see there are events which are contributing to errors and information. And on the right side, I have fields. So I can simply filter these fields. So filter these fields to find what is the contributing factor. So previously we saw that there are two pods, and one of the pods contributing this issue, which is the root cause. So I just select the pod. I can see there are two pods here: payment service 5C and something with S6. So it's highly chance that the pod with a number of logs will be the culprit here. Okay, so what I can do, I will just filter this. Now I am looking at the logs only for the one specific pod, and we have error and info. So I am just curious to know about the error logs. I will do the filtering. Okay, so now I have filtered one of the pod for looking at the error logs, which seems to be the root cause. So by clicking this, I can able to see the actual log information. So what is causing the issue? Here I can see there is a message: failed processing of payment because of the SSL certificate match. So this is the root cause for those errors. So there is a probability that there might be some updates, or the pods are showing some errors, and it appears that only one pod is throwing errors during this time period. So this can be due to many reasons which we are not sure at the moment. But finally we can see that this pod is throwing a code 400, and it is complaining about the failed payment processing, and there's a SSL certificate mismatch. Perhaps someone should have done something bad to this pod, so it requires an immediate remediation activity. As a sanity check, check for the other pod. So that one pod we see the issue is. Let's check other pod to see what the actual events will look like. So here I will remove the filter for error, and then so I will filter out the pod where I don't see any errors. Okay, so I can see only the information events, no error events for the other pod. So let me take a look into the one of the event. Okay, so here we see clearly that the message transaction processed. So this pod is not resulting in any error, unlike the first pod that is generating a lot of errors. So on this transaction looks healthy. It looks like the first pod has been manipulated manually, or maybe it's processed regardless, and we may probably now need to take some action. We know the root cause. One of the pod is not functioning proper, and now we need to make some actions so that it can be remediated, or some actions should be taken so that there shouldn't be any similar errors occurring again, for the user experience not to be bad. So yeah, so from here the ITSI solutions can be integrated with automation platform like SOAR, basically automation orchestration tool. So we can have some playbooks configured which can trigger in terms of destroying the current pod and recreating a new pod for the services to be up and running. So we can also take a look into the dashboard for the specific pods. So let me go back to the APM. Can show you the dashboard for this metric as well. So here, so we found the root cause, right? Now, what we can do more? I mean, so since I'm an analyst, I know this is causing something because of the misconfiguration of SSL certificate. And furthermore, if I want to create some new detectors, so detectors, nothing but then alarm or alert that we need to create. The detector or the signal that can trigger an incident when such thing happens, or if it breaches the threshold. So I can take a look into the dashboard. So this dashboard will have a lot of metrics. It will have the request rate, what is the latency, and what is the error rate. From here, I can quickly create a new detector. If so, this is a known issue. From next time, I want to trigger this an incident with clear message saying that this is because of a XML mismatch. So I can just create an alert here. New detector from chart. So I'll use the old editor, which is very easier to demonstrate. Here first we have a signal or nothing but the metric on which we want to trigger an alert. So next we will have the alert condition, whether you want to trigger it statically or whether if there is a sudden change and you want to trigger it. And third, we'll have the alert settings. What is the threshold that you want to configure? And then you will have alert message. So for example, in organizations, right, who doesn't have the observability capability, and the professional service people, they do the implementation the first time, so they can configure some sort of operation procedures in terms of a runbook, so that they can provide a URL here. So when this alert triggers, the users, the analyst can step into the runbook and they can try to find the root cause and remediate the actions. And we can proceed to the recipient if you want to do any sort of notifications, you can do, and finally activating the alert. This is how easy in Splunk observability suite, in terms of creating a alert or creating a detector uh, in a real-time monitoring. So this is how Splunk observability suite as a platform is very valuable to the customers in terms of monitoring and preventing the business not to undergo any damages in terms of revenue or so. And then finally, we will come back to ITSI tab. This is where the incidents are generated. As I told you, right? If we have some sort of automations configured, we can simply trigger a playbook. Like we can send it even to the playbook right now. Not configured since the demo environment. And trigger a playbook. So the playbook can immediately run automation to destroy the pod and recreate a pod with all the necessary configurations. This is how typically, Splunk enables the users or the organizations to get most value out of it in terms of observability and monitoring to reduce the minimum damage in terms of losing the business risk or the revenue. So yeah, so this concludes the demo. So I would like to just give an example of why observability is very important. So let me give an example with a very common scenario. So I assume everyone on this call would have a car or a motorcycle, right? So it has got a digital console, instrumental console. So at one point of time, the engine malfunction light glows up. What we usually think, okay, it's nothing. It can be due to some other reason, so we can ignore. And later point in time, we go to the service stations. So the service stations, they have the observability tool, which is the scanner, EBD scanner. So they will plug in the scanner into our car and they will scan. At that point of time, they will get to know there is a serious damage to our engine, which we ignored in the first place. So this is for for cars which doesn't have any observability, and it is completely reliable on tools to identify the root cause. So the same scenario, if we compare it to some premium luxury cars, for Merc, BM, and Mercedes, so they have a lot of sensors. So when something happens, they have a speed sensor, ABS sensors, they will have a no brake pads, warn sensors, they will have a engine level sensors. So whenever there is something happening to the car, you will get it in the MMDIC, multimedia instrument cluster display, that your oil level is getting down, or you have just 5,000 kilometers and then you need to do a service. You have only 5,000 kilometers with which your brake pads will last. So these are some observability tools. So what I'm trying to explain here is that the observability tools are very necessary and very important in terms of identifying something what is going wrong and remediate it as early as possible and not to cause the damage more. So that's a simple example that I want to bring up here. So with this, I think I will conclude my demo. Yeah. So if there's any questions, open to take them.
Yeah, thanks, Vikash. Yeah, it was a really awesome demo. So, yeah, I have one question here. So, uh, What does that mean, that noise reduction? Is it a false positive alerts that is reductions has
Yes,
happened?
that's correct. That's correct. So let me give you an example with the same scenario, like, So for example, if you're driving your car under wet condition, so you are going to a muddy road or a splash of water, the sensors, typically it might show some false alarms. It's not actual case. After a day or two, when it is warms up, the warning might go up. It's not actual cause. It is causing because of some other external factors, which is not a reliable and stable thing. So that's a noise. You may not need to address that issue at that particular point of time because it was causing because of some other factors. So those noises are being reduced automatically by the ITSI by using its ML and AIOps analytics in the backend.
Okay. Yeah, thanks. I have a couple of more questions. So, one more, as you said in the first demo, that there is a, if there is anything incident happened and it is automatically create some tickets, like ServiceNow tickets, and you can go that update and you work on that. Let's
Yeah.
say in within 5 minutes, is there any time specific if happened like two times? Let's say the incident occurred in 8:15 and again in the another incident came in 8:16. So the 8:16 one, whether that is updated with the same ticket, or how it is like, or it is
Yes,
a new
yes.
ticket will be created.
A good question. So it will group, as I told you, right? In ITSA, there's an episode. Episode will group the incidents based on its similarities. So it will group, and you can able to see the similar episodes, similar incidents.
Mhm.
I can show you that as well. If you are looking at a specific incident, you can also look at similar episodes at what time it has occurred, and you can also see the status of it. This is post triggering an incident, and you might know that your detector or alert that you have configured might be fluctuating up and down. So while configuring a detector and alert, there is a chance that you need to set the threshold. For example, detect when the CPU is more than 50 for a period of 5 minutes, meaning that for continuous 5 minutes, if the percentage of CPU is throttling above some percentage, you trigger an alarm. If not, don't do it. So likewise, we can able to optimize. So while doing the first time of implementation, you may not get 100% reduction or true positives, but over a period of time, you will know how to fine tune your detections, detectors, alarms, signals, and then at one point of time, once it gets measured, then you will have the noise reduction on a greater level.
Okay. Yeah, good. Another one, last one. So as you said that the RUM, the RUM, the real user monitoring. So in the real user monitoring, if let's say if I want to check like if the user session, I want to quickly check like what is the exact page is having that issue, and I want to train that. Let's say in the e-commerce site, you would like a t-shirt. So like from home page to then details page, then checkout, then payment page. So I want to see that, visualize that, like what exactly the most errors coming into a particular page. So that view can I see like here?
Yes, definitely, definitely. So, see, for example, the real-time user monitoring will populate some of the metrics for what it is being monitored or what is being configured, right? So you will have all the metrics appearing, and you will have the details, which service that is being affected, which is being a lot of errors. I think I have shown you the page during my demo as well. So here you can able to see for all the URLs that are being processed, what are the operations, applications, what are the browser versions, and everything. Like whatever happening in your application as a real-time user monitoring, you can able to see everything. And there are sessions should as well as there's a sequence of sessions happening, which will help us to understand, how the applications are performing when there is a huge load or huge hit, or when there is a no load, there's a no usage, or there is no hits with the website as well. So you will get the complete insight. So within the application, there are many URLs. For each of the URLs, you will get a session ID. That session ID will help you to understand, to deep dive. If there are any errors, issues, or you want to take a look into some other metrics as well as the RUM will help you to understand. So JavaScript errors, network errors, you can able to see everything. Some of tag is others. Likewise, the RUM can be configured such that you can able to monitor everything, whatever you want to, in terms of identifying the issues that are causing.
Okay. Okay. And also it will give funnel types just like Omniture that gives that how many users are coming through homepage to check out and how many are back out and all things you can see, right?
We can develop that view. It's not a bigger thing. So I mean, the bigger thing itself around identifying the issues or root cause. So the whatever you're asking is kind of business insights that can be easily built up.
Yeah. Okay. 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 Got it. Yeah. Thank you.
Thanks for that. I appreciate that, Vikesh. So I guess we are at the end of the hour. I'm sure there might be other questions as well. So Vikas will be noting down the questions and we will respond to those questions as well. In terms of some of the things that will happen next, whatever we discussed today, the presentation material, the link to the recording that will be shared with all participants. If you would like to reach out to us, please do feel free to reach out. Email ID is susan@positka.com. We'd be happy to discuss in more detail with you, or if you want to just engage, happy to talk. Thank you so much, everyone, for your time today. Appreciate everyone's patience. Thank you for the questions and have a wonderful day. Thank you so much.